For these examples, I will turn these straight lines in their trig mode because I see r's and thetas into their algebra mode. So really it's just getting a, b, and c, these coefficients. And it's pretty simple. A, which is the same thing as x, which is always cosine. B, which is y, which is always sine. And c is staring right at us, p. So right now, without doing any math whatsoever, I'm already 1/3 of the way done. How do I find the coefficient a? Simple. The angle right here is 60 degrees, so all it is cosine of 60 degrees. Using my unit circle, that's going to give me 1/2. And then sine of that same 60 degrees, again, sine 60 degrees, using my unit circle, that's going to be radical 3/2. So there's my equation. Now, I do want to clean this up because I don't like fractions. I'm going to multiply everything by 2. So 1/2 times 2 gives me x. Radical 3/2 gives me radical 3y. Multiply this by 2, and I'll leave my answer like this just to make it a little bit cleaner. Okay. If I take a look at my next example, the thing you do have to be careful with this one is your angle here, your phi, is actually negative 225 degrees. Okay. So if you want to use your unit circle, you have to think of it as the same thing as 135 degrees. Okay. So if I spin this way clockwise, it's the same thing as spinning 135 degrees counterclockwise. And that's just a matter of filling in all these values. So again, C is staring right at us. So I'm already 1/3 of the way done. Now it's just a matter of figuring out what is cosine of 135 degrees. Using my unit circle, that is going to be negative radical 2/2. And then sine of 135 degrees, using my unit circle, that's going to be positive radical 2/2. And again, I don't like fractions, so I'm going to multiply everything by 2. So that's negative radical 2x plus radical 2y equals 14. So here is my straight line in algebra mode as opposed to trig mode.